Last time we built a simple chat server. Today we are going deeper. We are going to stop relying on standard text-based protocol and design our own binary communication protocol. We will solve the TCP streaming problem using a custom codec, implement a challenge-response handshake using RSA encryption to verify our clients. And I will show you exactly how to structure a protocol that is memory safe and fast. Let's get into the code. So in the server binary, I have structured everything. The client struct and the peer map type, it is in the data.rs file, and I added some other fields as well, like username, user ID, public key, and session key. In the main, we just have TCP server, and we are listening for the clients. And in the handle client function, last time we used a framed instance, which is coming from Tokyo util codec, and we used line codec here. Let me show you the code. So here is the main.rs file, and we used line codec last time, which is returning lines from the TCP stream. But we will use our custom codec here, which is packet codec, which is coming from library protocol and the packet. And by using this packet codec, it will return packets, our own custom packets. So let's see how to structure a protocol. So I will create one module in the library create with the name protocol. In the codec.rs file, we have to implement the decoder and encoder for our packet. Okay, and let me explain what is this packet. So in the packet.rs file, we have our struct called packet. It has header, type packet header, and payload, which is vector of bytes. So the packet header, it will have one magic byte. Magic byte is for security check. So while reading a TCP stream, we will check the magic byte. If it is not expected, I mean it is not the same as the server is expecting, then we will reject the packet. This is the version number, operation code, payload length, and an optional ID. So in the codec.rs file, I will delete the complete codec and we will code it from scratch. I will create public struct packet codec, and we would like to implement decoder from Tokyo util codec for our packet codec. In order to implement a decoder, we have to add item, error, and decode functions. Okay, so let me click on quick fix, implement the missing members. Perfect. So item is nothing but a type. So we are implementing for the packet type, and packet is coming from create protocol packet. Now we have to implement the decode function in order to parse our packet. For now, I will put it on hold and we will implement the encoder first. So I will say implement an encoder for the packet type for packet codec. Same here. Type is going to be error, and we need encode is a method. Okay, it is taking item, which is a packet, and we have one destination buffer. So we will encode our packet into bytes and put it into the buffer. Perfect. So let me define our encoding protocol. So protocol is something like this: header length, header bytes, and payload bytes. So this is our protocol. So what we will do, we have the item. So first we will get the header bytes. So header bytes, item dot header dot. There is one method called 2 bytes. It will return us the vector of bytes. Perfect. So we have the header bytes. Now we will get the payload bytes. And payload is already. Now we need to add these bytes into the buffer. So first I will say dst dot extend, and I will say header dot length as u8. So the first byte is added. Second we will say extend from slice, and we will add our header byte. Same for payload bytes. Extend payload bytes. Done. And this function is returning a result of unit type or the error. We didn't encountered any error, so we will return okay with the unit type. So this is it. Or an encoder function is done. Now we will work on decoder. Let me just paste the protocol here. If we check the documentation of decode function, so it is saying attempt to decode the frame from the provided buffer of bytes. Okay, there is one thing. If the bytes look valid but frame isn't fully arrived yet, then okay none is returned. It means TCP is the stream, and it is possible that we didn't get the full message yet in the buffer. So if full message is not arrived yet, then we will return okay none, and we will wait for full bytes to arrive. So first we will check if let me remove this underscore length. If length is less than 1 or the header byte, then we will just say return okay none. Let's consider we got the header byte. Now let's read the header length. So I will say header length. Header length is going to be the 0th byte of the source as u size. Perfect. Now I will check again if source has the complete header byte plus header length. If it is not, then I will again say okay return none. Now let's say if header byte and header length both are arrived, both are present in the buffer, then we will read the header now. Okay, now let's parse the header. Now we know that the first byte is the header length, and header starts from the second byte. Okay, so I will say uh, source. Let's take the reference of source and from 1 to complete header size. So we get the header bytes. Let me mark it as a header bytes, and we will try to parse the header. So I will say packet header, and there is one function named parse. Here we can check the magic byte. So I will say header dot magic byte. If it is not equal to 44, then we will just return an error. Now we will try to read the this much length from the source. So we already extracted the header byte and the header length. We will advance this much byte in the source. So I will say source. Before advancing, we can do one more check, source dot length. If it is less than, we can define one more variable here, something like this, payload size or the packet size. So our complete packet size will consist one header byte, header length, and the payload length. So if complete packet size is not arrived, source length is less than this size, then we will say source dot reserve this much byte. How much? Packet size hyphen the remaining size. It is SRC. And we will return okay, none. Perfect. I will just advance the header size because we already read the header. We don't need it now. Now I will try to read payload bytes. So payload bytes is going to be source dot split to payload length. Now we have the header and the payload bytes. Now we can construct the packet and I will say some packet. So we have the header. Payload is going to be payload. Okay, we need to use two vector. So header and payload. Perfect. So this is how we can parse our packet from the stream of bytes. We have our server here and we are the client. Let's say I want to connect to the server. So what will happen? Client will send the username and the RSA public key. Okay. So packet is received by the server. Server will process the login packet, extract the username and the RSA public key, and try to parse the RSA public key. Now, after RSA public key is validated, server will generate 12-byte nonce and send it back. Server send the acknowledgement to the client. Now client will sign the nonce with the respective private key, the RSA private key, okay, and send the signature to the server. Server will receive the signature, try to verify it with the public key, which client send it in the login packet. And if it is verified, server will send the encrypted session key to the client. So this is the complete procedure of handshake we are following. So let's see how it is happening. So I am showing in on the server side only right now. So first we will wait for the login packet. If there is some packet, we will store it. Now we will check the operation code first. If operation code is not login, then we will return from here. Okay, if operation code is login, then we will proceed. I will try to parse this public key into the RSA public key using the crypto module. So there is one function called parse public key from string. So I will pass the public key and get the RSA public key. If there is any error, I will just return none, and the handshake process will stop right there. It won't complete. Now, when the public key is completely okay, we will generate session key and the nonce. Now we have to send these nonce to the client. Now this is received on the server on the client side, and the client will sign this nonce and it will send the signature back. This is the expected behavior actually. Let me isolate this one as well. Now we send the nonce. Now we will wait for the signature from the client. I will check the operation code. If operation code is signature, then we will continue, otherwise we will return. We will verify the signature. So from the crypto library, there is function verify signature. It will take the public key reference and the nonce and the signature. Signature is present in the payload. And if signature is not okay, we will return from here. If it is okay, then we will send the encrypted session key. See, we also have to handle the client handshake on the client side. So I already coded the client application. So I'm going to use that application only. So let me open the terminal. So I will run the server binary. So our server is perfectly running on port 8080. Now I have to run the client application as well. So I will say cargo run hyphen bin and client. And the client application will take two command line arguments. The first is the server URL, and second is the path of the ID RSA, path of the RSA key. So I'll press enter. Let's add the line break in our server files. That would be much helpful. Let's run this server again. So as you can see, first client sent the login packet sent, and server was receiving the login packet, and it successfully received the login packet. Okay, and public key was correct, so it sent the login acknowledgement packet here, and client was receiving the listening for the login acknowledgement packet, and client received successfully. It signed the nonce and sent the signature packet, and server was listening for the signature packet, and it received successfully. It tried to verify it. Signature was verified successfully, and after signature was verified, we sent the signature acknowledgement packet with the session key. And of course, client was also listening for the signature acknowledgement packet, and it received, and connection was successfully. And this is my user ID. So right now protocol is the same as before. I will use the user ID, try to send the message, and I receive the message. Let's try one thing. If I try to connect to one more client, one is already connected. Right, master. So in the client application, if it is encrypted, then it will ask for the passphrase. So I will enter it. So as you can see, this client is also connected, and we received the same log messages as here. You can see these are the log messages coming from the second user. I have pushed the full source code for the protocol and the crypto modules to GitHub. You can find the link in the descriptions. If you found this dive into binary protocol helpful, hit the like button and subscribe. Thanks for watching. I'm Vivek, and I'll see you in the next one.